So today we are going to do the second part of our video tutorial on trig integrals. Now, like I explained, a trig integral is an integral which only has a trig functions in them: sine, cosine, tangent, and secant. Now, in the previous tutorial, I taught you how to handle one such type of integrals, and those are integrals which have only sine and cosine, and that too either the sine power or the cosine power has to be odd. And what we did was then we reserved one of those odd powers to the corner, and then we converted the remaining even power to the opposite using Pythagorean, and then we put a u substitution. Now we are going to look at the second type of integral that we can handle using our techniques. And as an integral like that will look like this. It will have a tangent or a secant, but the secant power will be even. So here is an example. Here is the example. The integral is a secant tangent integral, and the secant power is 4, so the secant power is even. Okay. Now the way we handle this integral is kind of similar to how we did the sine cosine thing, where sine or cosine has an odd power. What we do is we take this even power and we split it into two parts. But this time we actually split it in, we separate a secant squared and throw it to the end. Okay, so we have secant the 4, tangent squared, that's our integral. What we do is we split it into two. So secant squared, we split it in such a way that we can throw a secant squared into the corner. So we split the secant 4 so that we can throw a secant squared into the corner. The next step would be to now in the previous type, the next thing was to convert the remaining power to the opposite. Okay, we do the same thing here, except that the opposite of secant would be tangent. So we convert the secant squared into tangent. And once again, just like before, we can use a Pythagorean to do that. Because secant squared is 1 plus tangent squared. We can put that here, and then this becomes 1 plus tangent squared. And then we still have the tangent squared, and we have secant squared dx, which we reserved at the end. Now in the previous type, the next step was to put a u substitution, which was u equals the opposite. Here too we do the same, except that now the opposite is tangent. So we put u equals tangent x, which will make du equals secant squared dx. Now you will see the prudency of what we did. Now the reason why we separated the secant squared dx right to the corner with the dx was that when we put that substitution, the du becomes exactly that leftover part. So we can actually nail the leftover part with the du. Alright, so the next step would be to just plug in. So we put 1 plus a tangent squared. It will be now, tangent is u, so it will be u squared. And we have another tangent squared here, so that will be again u squared. We have secant squared dx, which is exactly du. So we put that as du. Alright, and now we are all set to integrate. Now the easiest way to integrate this would be to distribute the u squared inside, in which case we will get u squared plus u to the 4, and when you integrate that using power rule, you get u cubed over 3 plus u to the 5 over 5 plus a constant. We are almost done now. The only thing left to do would be to plug back the substitution. So u is equal to tangent x, so this will become tangent cube x over 3 plus tangent 5x over 5 plus c. I will leave you with an exercise, a video exercise, which is our video exercise 3, is to evaluate secant to the 4th power. Now once again you will see that this can also be tackled in this manner because we have a secant tangent thing and the secant power is even. Now before I leave, let me just rush through the technique again. What we did was we have an integral which is secant even power. We took and separated a secant squared this time and threw the secant squared to the end. So when we throw a secant squared to the end, we are left with another even power here. Then we use Pythagorean to convert that into tangent, and then once it is converted, we put u equals tangent, which will take care of the derivative of which will take care of the leftover part, and then we will have a simple integral involving u. That's it for this video tutorial. So we have now done two types. One where we have a sine or a cosine with one of them having an odd power, and the other with a secant and a tangent where secant has an even power. We have not yet attacked the situation when both sine and cosine powers are even. We will do that next. And also we need to look at the situation when secant power is odd. Well, if there is odd secant power and the tangent has an odd power too, then there is a way that we can nail this. Okay, so we will look at these things shortly. Okay, thank you. Have a great evening.